Hey everybody, this is Mr. Houston, and I wanted to just quickly review with you how to write and solve a system of linear equations. So when you have a word problem, one of the best things to do is always to read the problem through before you try to start circling information or trying to solve. I've already read this problem, so I'm just going to go ahead and get to work with it. Let me switch colors here. So Michaela runs at a speed of 42 meters per second. So right away I'm noticing that we have a rate, and John runs at a speed of 3.7 meters per second. So there's another rate, and I've got two different people. So right there I'm probably thinking two different equations. If Michaela starts running when John is 10 meters away, so we have basically a starting point. So if I have a rate and a starting point, I'm really thinking of slope-intercept form, or y equals mx plus b. For Michaela, she runs at a speed of 4.2. John runs at a speed of 3.7, and it says that he's starting 10 meters away. So right away I have my two. Oh, that doesn't look very good. Let's make that better. Right there I've got my two linear equations, and so I know that if I want to figure out the solution, I'm going to have to solve this system of linear equations. One way that we can do that is we notice that they're both equal to y, so we can actually set those two equations equal to each other, and then we could solve this like a straightforward linear equation problem where we're just solving for x. Another way we can do this, because they're both in slope-intercept form, it's going to be very, very easy to graph them and find the solution that way. So we have y equals 4.2x. Oh, goodness gracious. And we had our other equation, y equals 3.7x plus 10. And so remember, when we're looking for a solution on a graph, all we are really doing is just looking for where those two lines intersect. And if we tap on our graph here, we can see, okay, they intersect at the point 20, 84. So I know that's going to be my solution to that system. But we always want to go back and read the question, how many seconds will it take for Michaela to catch up to John? So our time we were using was x, so it's going to be 20 seconds. We're using that x coordinate for our answer. All right, let's take a look at the next problem. A football team scored 7 times for a total of 37 points. So again, I've got two different pieces of information here. Each field goal is worth 3 points, so maybe I want to let x represent field goals. And each touchdown with an extra point is worth 7, so maybe I want to let y represent my extra points. So they scored 7 times. I can write that as x plus y equals 7. And then I can talk about the value of those scores. So I can say 3x from each field goal, and 7y gives me that total of 37 points. So once again, I've got two equations, and so I can solve this as a system of equations. Because they're both in standard form, this lends itself really well to solving by elimination. When you do that, you want one of your variables to have the same coefficient. Since right now this is both x and y, I could actually multiply this entire equation by 3. And I'm going to do that right here. So 3 times x is 3x, 3 times y is 3y, and 3 times 7 is 21. And now I can just simply subtract those equations, and it's going to eliminate the variable. 3x minus 3x is 0. I don't even have to write 0, because 0 plus anything is what it is. So I'm going to put 4y, because 7y minus 3y is 4y, and then 37 minus 21 is 16. And look at how easy this equation is going to be to solve. All I have to do is just divide by 4 on both sides. And I love elimination for this reason. So y equals 4. Now y represented my touchdowns. So how many touchdowns did they score? 4 touchdowns. And then I can go back to my original equation of x plus y equals 7, and I can figure out that indeed if I subtract 4 on both sides, they scored 3 field goals. So I've got 3 field goals and 4 touchdowns. 3 field goals and 4 touchdowns. If I wanted to use a different method of solving this problem, then what I would do is I would solve both of those equations for y so that I could then graph them and look for the intersection like that. So maybe I would take my first one of x plus y equals 7, and then I would subtract x on both sides. So I would get y equals negative x plus 7, and I wrote the x first just so it would look more like a slope-intercept form like I'm familiar with. And then, of course, I would have my other equation of 3x. That's ugly. Let's try that again. 3x plus 7y equals 37. And I would subtract 3x to both sides. Remember, we're just changing from standard form to slope-intercept. So I end up with 7y equals negative 3x plus 37. And then I can divide by 7 so that I end up with y equals negative 3/7 x plus 37/7. Now I know that's really ugly looking, but trust me, it doesn't matter that it's ugly as long as it's in slope-intercept form. I can then go to Desmos and graph it. So we had y equals negative x plus 7, and we had y equals negative negative 3/7, sorry, negative 3/7 x plus 37/7. And you can see where they intersect at 3, 4, x equals 3 and y equals 4, which is exactly what we found, 3 field goals and 4 touchdowns. All right, let's look at our last problem. At a concession stand, hot dogs are sold for $3.75, so there's something, let's call it x, for $3.75 each. Sodas, there's my other thing, that's our y, are sold for $2 each. So, of course, I know that I'm going to have 3.75x plus $2 times y. And if I keep reading the problem, it doesn't tell me until later on Carlos spent a total of $30.25. So there's one equation, but in order to solve a system with two variables, I need two equations. The number of hot dogs that Carlos purchased was 3 more than the number of sodas. So the number of hot dogs, that was x, is 3 more. So I know it's going to be plus 3. 3 more than what? Then twice the number of sodas. So 3 more than 2y. So because this equation is already solved for one variable, it actually makes it really easy to take this part and substitute it in for the other variable. This is a method of solving called substitution. It's not everybody's favorite. I kind of like it, but it's not for everybody. That's okay. So I'm just substituting that equation of 2y plus 3 in for x. And then once again, now I just have a straightforward linear equation that only has one variable that I can then solve. I'm not going to do that because I know a lot of you guys are going to want to just use that solving by graphing method. So let's just review that one more time. If I just take my original equation of 3.75x plus 2y equals 30.25, and then we'll just subtract 3.75x on both sides of the equation, I'm left with 2y equals negative 3.75x plus 30.25. And then, of course, I can divide by 2 everywhere. And I'm left with y equals negative 3.75 x over 2 plus $30.25 over 2. And my original equation over here, this one, I could solve that for y, but I don't actually have to. Let me show you on Desmos real quick. Let's graph that. We had y equals negative 3.75 over 2 x plus $30.25 over 2. And we had our other equation, which was x equals 2y plus 3. Because it's solved for one variable already, it will graph it without us having to change it into slope-intercept form because it's already solved for one variable. There's my intersection, 7, 2. So we know that our solution is going to be 7, 2. But we also always have to read the question. We've got to know if Carlos spent this much money, how many hot dogs did he purchase? We're not looking for the full solution. We're just looking for the number of hot dogs. And our value was X for hot dogs, so our answer is, of course, 7 hot dogs. So there it is. Make sure you're always reading the question carefully, and regardless of what system of equations that you're given, you know that you have different methods you can use to solve. You can use substitution, you can use elimination, or you can change both equations into slope-intercept form if they're not already in slope-intercept form, and then you can graph them. I hope you enjoyed this. I hope you're studying hard and you're reviewing. One more quick tip, don't forget that when you're dealing with a system of equations, most of the time we're looking for the intersection, but sometimes you'll get a problem like this, where we end up with parallel lines because they have the same slope. If they never intersect, then remember there's no solution. And then sometimes we'll run into a problem where maybe our other equation is something like this. X equals, we'll say, 2y minus 12 all divided by all divided by 6. And as you can see, those end up becoming the exact same line. So in that case, there are infinitely many solutions. So remember, we've got one solution where they intersect, no solutions where they're parallel, and infinitely many solutions where you have the exact same line. I hope this helps. Have a wonderful day.